Here we go. We have a question, remove loop in linked list. So you have given the head of a linked list that may contain a loop. A loop means that the last node of the linked list is connected back to a node in the same list. Our task is to remove the loop. So we have given this linked list and 4 is connected. So we need to just disconnect 4 next pointer. So the node will look like 1 next to 1, then its next is 3, 3's next is 4, 4th next is null. And we have given this. We don't have any loop, so we don't need to return the loop. We don't need to disconnect the loop. In this we have a loop. So this is connected, 4th next is connected to 1. So we need to just disconnect the 4th next. So we have given this. And now let's build the approach. So we have given this node, we're gonna apply fast and slow pointer. So fast pointer points to head, slow pointer points to head. Fast will make a jump, 2 steps, fast will add 2 steps, slow will add 1 step. Is it equal? No. Fast will again jump 2 steps and slow will jump 1 step. Fast will again jump 2 steps, then slow will jump 1 step. Fast will jump 2 steps, slow will jump 1 step. Is it equal? No. Fast will jump 2 steps, slow will jump 1 step. Is it equal? Yes, now it is equal. Then we need to disconnect the loop. So I will reinitialize my slow pointer to head, and in the previous video I have already discussed that this is your A, and let's suppose they will meet, fast and slow pointer will meet at this point, so this is C. So I have proved that A is equal to C. A is equal to C, and as you can see we have a single node, and its next is a connected node. So yeah, A and C is equal. Now we don't need to reach this node, we need to just reach its previous node. So we're gonna check fast next not equal to slow's next. We will reach till the previous node. So this is the intersecting point. We don't want to reach here, we will reach till its previous point. So as you can see, slow's next and fast next is equal. While this condition is not equal, slow will make 1 step and fast will also make 1 step, but in our case it is equal, so we will not gonna take any further steps, and we just need to remove the next pointer. So fast is our last node, so its next is connected to this intersecting node. So we're gonna just do fast dot next is equal to null. So we will just remove this node, and no need to do anything, and we have just disconnected the loop. Same thing applies here, slow pointer here and fast pointer here. So slow will make 1 step, fast will make 2 steps, slow will make 1 step, fast will make 2 steps, slow will make 1 step, fast will make 2 steps. Now fast is null. If your fast is null or fast next is null, if we have odd number of nodes, fast next will be null. If any of these condition is true, we're gonna just return from that point. It means there is no loop. Let's apply the same thing here, but we cannot apply. You will see that we have an issue here. Slow pointer here, fast pointer here. Fast will jump 2 steps, slow will jump 1 step. Fast will jump 2 steps, slow will jump 1 step. Fast will jump 2 steps, slow will jump 1 step. Fast will jump 2 step, slow will jump 1 step. fast will jump 2 step, slow will jump 1 step, fast will jump 2 steps, slow will jump 2 steps, slow will jump 1 step. And now at this point our slow and fast pointer is equal. Yes. So the next step is to reinitialize your slow to head, but it is already pointing to head. And the next step is to iterate till while our slow next, as I've already discussed this point, while slow next not equal to fast next. Yes, we have this thing, and slow next and fast next it is equal. So we will remove this node, remove this connection, but this is not the expected answer. We need to remove sixth next. We need to remove sixth next. So it will create an issue if and only if your slow and fast pointer reaches the head node. It means the last node next pointer, the last node next pointer the last node next pointer points to the head node itself. So it will both meet at the same point, means the head point, and we are just removing this connection, so it will create an issue. So we need to think optimally. So what we can do, one way is to, like, if you are slow and fast equal to head, so what you can do, you will iterate till the last point, and then what you will do, slow next will become null. Yes, this is one of the answer, but we can still optimize this. We don't need to travel till the end. We can create one more pointer name as previous pointer. Now let me show you the dry run. Slow will jump 1 step, fast will jump 2 step, but before jumping the slow pointer we will initialize previous. uh, so slow and fast is here. So before, so fast will take 2 steps, and before slow taking any further step, we need to initialize previous to the slow pointer, then fast will move ahead. Just bear with me. Fast will take 2 steps. Before slow jumping any further step, just reinitialize your previous to slow, then slow will move ahead. Fast will jump 2 steps. Before jumping slow, reinitialize previous, and then slow will jump. Fast will jump 2 steps. Before jumping your slow, reinitialize your previous, and then slow will jump. Fast will jump 2 steps. Before jumping your slow, reinitialize your previous, then slow will jump. Fast will jump 2 steps, and before jumping your slow, reinitialize your previous, then slow will jump. At this point it is equal, and previous is pointing to previous is pointing to the last node. If your fast reaches the head node, means we need to remove the last node connection. So we will write a separate condition. If your fast is equal to head node, just remove the last node next connection. So previous dot next will be null, this is the special case, and then just return it. No need to do any further steps. So I will just remove this connection, and we are good to go. That's it. Now let me show you the code. We have slow pointer, fast pointer, and previous pointer. While this condition holds, fast will take 2 steps before jumping slow, previous will reinitialize to slow, then slow will jump. Slow and fast, if it is equal, return, just break out. If this is a singly linked list, we don't have any loop. If fast is null or fast dot next is null, just directly return from this point. If this is your if we have a loop and the loop connected to the head node, means our fast pointer connect to the head node, we need to remove the connection from the previous, from the last node. So previous dot next will be null, and just return it. Then we have a connection to any node in between. So slow will reinitialize to head. So I have given you a proof that a is equal to c. So we don't need to point to the intersecting node, we need to just point to the its previous node. So slow and fast next is equal to node is not equal. Slow will jump one step, fast will jump two step. Fast next will be null, not slow next. Not slow next. Why not slow next? So slow will be here, fast will be here. Fast will reach fast will reach this step, slow will reach this step. And if you, so it is connected. So if you do slow next will be null, slow next will be null, it means you are disconnecting this connection. So it will look like this, it will look like this. And we want the connection to like this. So that's why fast next is equal to null, fast will point to the last node. So this is the condition, and that's it. Let's submit this and it will work just fine. Let's talk about time and space complexity. In this code, the time complexity is order of n, space complexity is constant. Code is provided in the description box. If you guys have any doubt, feel free to ask in the comment section. Thank you all for watching.